Hi everyone, this is Mrs. GA and today we're going to learn about special right triangles. So in trigonometry there's two special right triangles that you're going to need to know and have memorized. The reason why is because they are so useful. We use these specific angles so much that it's really good to know the ratio of the side lengths of these two triangles. So the first one is called a 30, 60, 90 triangle. We call it that because one angle is 30, one is 60, and one is 90 degrees. So for any 30, 60, 90 triangle, the side lengths will follow the ratio of 1 to root 3. Now, it is really important that you're able to place the side lengths across from the correct angles. So I always start at 30 degrees, the smallest angle, and I go across. That side length is 1. The hypotenuse is 2. And across from 60 is always root 3. So 1, 2, root 3. Now for a 45, 45, 90 triangle, again we have two 45-degree angles and a 90-degree angle. The side lengths always follow the ratio of 1, 1, square root of 2. So notice that the two legs of the right triangle are both 1, and they're both the same length because this is just an isosceles triangle, so the base angles are congruent, so are the two legs. And then our hypotenuse is always root 2. So we can actually use these similar triangles or these special right triangles, and we can create a similar triangle ratio to help us find missing sides of our special right triangles. Okay, let's go here down to example 1. We're actually going to skip example A. That somehow ended up, it was from a different set of notes, so ignore example A. So here we're going to be using similar triangles to solve these special right triangles. And when it says to solve the triangle, it means find all of the missing parts. So here, this is 30 degrees, this is 90. This must be 60 degrees. So we see that we have a 30, 60, 90 triangle. So one way you can approach these is you can draw your own 30, 60, 90 triangle. I like to try to make it look as similar as possible to the original one, so the same orientation. Except for this triangle, we're going to mark it up with the values from above. So remember, we start with 30 and we go across. This length is 1, our hypotenuse is 2, and the last leg is root 3. And now, since we have two triangles that have the same three angles, these are similar triangles. So we know that their corresponding sides are going to be proportional. So we look and we are going to match up the corresponding sides. So we can see here that this side length of 1 goes with the 10, the 2 goes with x, and the root 3 goes with y. So we can set up some ratios to solve for x and y. So we can start with x over 2. We'll solve for x first. We can say x over 2 equals, and then we need to set it equal to a ratio where we know both values, so it will be 10 over 1. And then if I multiply by 2 on both sides, we get x equals 20. And we can do the same thing to solve for y. So we can say y over square root of 3 equals 10 over 1. We multiply both sides by square root of 3, and we get y equals 10 times the square root of 3. And there you have it. So again, we can draw our own special right triangle, hence creating a set of similar triangles, and then we know that the side lengths are proportional. So we can find any missing side using those proportions. Okay, let's look at this next one. So here you can see that we have a 45, 45, 90 triangle. And so that means we're going to draw our own. Again, I'm going to make it look as similar as possible. 45, 45, and 90. Okay, so we know for 45, 45, 90, these both have lengths of 1, and this has a length of square root of 2. So again, we can match up the corresponding sides. So 7 goes with 1, y goes with 1, and x goes with root 2. One thing you can always know right off the bat, the two legs are always going to be congruent because, again, it's an isosceles triangle. So we can say right off the bat that y is also equal to 7. And then to solve for x, we set up our proportion. So x goes with root 2, just like 7 goes with 1. And then we multiply both sides by root 2, and we get x equals 7 root 2. There you have it. Okay, let's try a couple more together. So here we see that this is a 30, 60, 90. So let's draw our own, and again try to make it the same orientation so it's easier to match up the corresponding side lengths. This is 30, this is 60. Okay, so we always start across from the 30. So that's 1. The hypotenuse is 2, and then the last leg is root 3. So we can match up the corresponding parts. We know x goes with 2, y goes with 1, and 2 root 3 goes with root 3. And let's set up our proportions. Let's start by finding x. So we can say x over 2 equals, and now we need a set where we know both values. So we'll do 2 root 3 over root 3. So here, because we have root 3 divided by itself, it becomes 1, and then I can multiply both sides by 2, and we get x equals 4. Okay, let's set up a proportion for y now. Y over 1 equals 2 root 3 over root 3. So y equals 2. There you have it. Okay, let's look at this next example. So here's another 30, 60, 90. So let's draw our own in the same orientation. So 30 degrees, 60 degrees. So always start across from 30. That's 1. Hypotenuse is 2. Last leg is root 3. And let's match up some parts. So x will go with root 3. 6 goes with 2. And y goes with 1. Let's find x first. So we can say x over root 3 equals, so now we'll use 6 over 2 because we know both values. So 6 over 2 is 3, and then we can multiply both sides by root 3 to get x equals 3 root 3. Okay. Let's set up a ratio to find y. So here we have y over 1 equals 6 over 2. Y equals 3. There you go. All right, and for this last one, here we have a 45, 45, 90. So let's draw our own. So we create similar triangles. Remember, we always mark up the legs as 1 and 1, and our hypotenuse is always root 2. So we can see that 5 root 6 goes with root 2, A goes with 1, and B goes with 1. However, A and B should be equal just like these two are equal. So we can find either A or B, and then that will tell us the other one as well. So let's set up our ratio for A. So A over 1 equals 5 root 6 over root 2. So A equals, remember when you're dividing two radicals, as long as they're both square roots, we can divide within. The 5 still stays on the outside, so this actually becomes 5 root 3. And if A is 5 root 3, we know that B is also 5 root 3. And there you have it. So again, we can always solve for missing parts of a special right triangle by drawing our own and then using similar triangle proportions. Okay, we can also use special right triangles to help us evaluate sine, cosine, and tangent of 30 degrees, 60 degrees, and 45 degrees. which is something you could do with your calculator, but it's something that's really nice to be able to do without your calculator. So if you set up your 30, 60, 90, we can use this triangle to help us find the sine of 30 degrees, 60 degrees, and 45 degrees using this triangle. So let's start by finding the sine of 30 degrees. So remember, sine is opposite over hypotenuse. So the sine of 30 degrees is 1 over 2. The sine of 60 degrees, so now we have to start here, we still do opposite over hypotenuse. Here we get root 3 over 2. And then for 45 degrees, you can use either one. If you do opposite over hypotenuse, it's 1 over root 2. Now, typically we don't leave our answer like this. We're going to do what's called rationalize the denominator. So to do that, we're going to multiply the numerator and denominator by root 2 over root 2, because we don't like to leave square roots in the denominator. And what that gives us is square root of 2 over, this becomes square root of 4, which is 2. So root 2 over 2 is how you commonly see 1 over root 2. Okay, now let's do cosine. So let's start with cosine of 30 degrees. Remember, cosine is adjacent over hypotenuse, so root 3 over 2. For 60 degrees, here's 60. The adjacent side is 1, the hypotenuse is 2, so it's 1 over 2. And for 45, it's 1 over root 2, so it's the same as the sine, so we'll just write it as root 2 over 2. And then for the tangent of 30, so remember tangent is opposite over adjacent, so that one is 1 over root 3. But that same process, if you multiply the numerator and denominator by root 3, we get root 3 over square root of 9, which is just 3. So it's more commonly seen as root 3 over 3. Now if I do the tangent of 60, opposite is root 3, adjacent is 1. So it's just root 3 over 1, which we can just write as root 3. And then for 45 degrees, you can use either one. Opposite is 1, adjacent is 1, 1 over 1 is 1. So now we have some values that we can use to help us solve these triangles in a different way. So now we're going to use trig ratios to find missing sides of our special right triangles. So let's look at this first example. So let's say we'll be working with this angle, 60 degrees. That means this would be the adjacent side. This is the opposite side, and this is the hypotenuse. So let's start by finding x. If I want to find x, I have to use the hypotenuse, and I have to use the value we know, which is adjacent. So you ask yourself, which trig ratio uses adjacent and hypotenuse, and then we would know that that's a cosine. So we could say the cosine of 60 degrees equals 2 over x. Remember, adjacent over hypotenuse. Let's multiply both sides by x, so it's no longer in the denominator. X times the cosine of 60 degrees equals 2. And then we can divide both sides by the cosine of 60 degrees. So here we get 2 divided by the cosine of 60 degrees. So instead of using a calculator, because sometimes you won't have a calculator available, we can use the value that we found above. We know from our special right triangle that the cosine of 60 degrees is 1/2. So I can just replace that with 1/2. 2 divided by 1/2. So remember here we have to multiply by the reciprocal, so 2 times 2 over 1, so x equals 4. And there you go. So let's see if we can do the same for y. So again, we look at our angle and we say, okay, which trig ratio involves opposite and adjacent, the value we know, so that would be tangent. So we say tangent of 60 degrees equals y over 2, multiply both sides by 2. And then from above in our chart that we filled out, we know that the tangent of 60 degrees is square root of 3. So this becomes y equals 2 root 3. So we solve for x and y using trig ratios, and we could do this completely by hand without using a calculator. All right, let's try example B. So here using 30, if we're using 30, this would be our hypotenuse, this would be the opposite side, and this would be the adjacent side. So let's start by finding A. So we say which ratio uses adjacent and hypotenuse, and that would be cosine. So the cosine of 30 degrees equals 6 times the square root of 2 over A. So we're going to multiply both sides by A. A times cosine of 30 degrees equals 6 root 2. And then we'll divide by the cosine of 30 degrees, which is a value we know from above. We know that the cosine of 30 degrees is root 3 over 2. So it's 6 root 2 divided by root 3 over 2. So remember, when you divide by a fraction, we actually have to multiply by the reciprocal. So it's 6 root 2 times 2 over root 3. So here, we can multiply the 6 and the 2 because those are non-square roots. So that gives us 12 root 2 divided by root 3. And then the last thing we need to do is rationalize. So if we multiply the numerator and denominator by square root of 3, we get 12 times the square root of 6, because I can multiply these two. And then my denominator becomes the square root of 9, which is just 3. And then one extra step, now that we see this, we can actually simplify this because 12 divided by 3 is 4. So a lot of work in the simplifying process, but again, all of this can be done simply by creating a trig ratio. Okay. Oh, sorry, we have to find B before we move on to the last example. So for B, again, we have this angle. So what involves opposite and adjacent? And that would be tangent. So the tangent of 30 degrees equals B over 6 root 2. B equals 6 root 2. So I multiply both sides by 6 root 2 times the tangent of 30 degrees, which is a value we know from above in the chart we made. So B equals 6 root 2 times root 3 over 3. So here I can multiply my two square roots. So it becomes 6 root 6 divided by 3. And then I can divide my non-square roots. So it becomes 3 root 3. There you go. Okay, for the last one, here we know right off the bat that this leg should be congruent to this leg. So we know that n equals 2 root 2 because it is an isosceles triangle. It's a 45, 45, 90. But we still need to find m. So we can use either one here. So let's say we're going with reference to this angle. We would call this the opposite side, and we would call this the hypotenuse. So you say which ratio uses opposite and hypotenuse, and that would be sine. So we say the sine of 45 degrees equals 2 root 2 over m. So multiply both sides by m. And then we have to divide both sides by the sine of 45 degrees. And then from here, we know that the sine of 45 degrees is equal to root 2 over 2. So we're going to multiply by the reciprocal. So 2 root 2 times 2 over root 2. This cancels out with this, and we get m equals 2 times 2, which is 4. Okay, so that is all for today's video. That was our little introduction to special right triangles. Thank you so much for watching.